Hello everyone, I hope you are doing well. So in this video, we are going to discuss Leetcode problem of the day, and today's problem is minimum time visiting all points, and it is an easy level problem. So the problem basically says that we have been given a 2D integer array of points, right? And also we have this 2D plane. Now let's say this is the integer array and we have to traverse through these points, right, in this sequential order only. Right. So we have to go from 1 1, then 3 4, then minus 1 comma 0. Now while going from 1 1 to 3 4, it is possible that we might visit any other point that is after these two in the sequence, and that is totally allowed. So basically what I am saying is, let's say this is point 1 1, 1 comma 1, this is point 3 3, and this is point 2 2, 2 2. And let's say our array is 1 comma 1 is the first element, then we have 3 comma 3, so this is 3 3, and then we have 2 comma 2. That means from 1 comma 1 we have to go to 3 comma 3. So I can go like this. So let me just draw another line. I can go like this, right? This is allowed, and I can surpass this particular point. I can traverse through it. But since 2 comma 2 is after 3 comma 3, then I'll have to come back from 3 comma 3 to back to 2 comma 2, right, like this. So this is what they are trying to say, that we can surpass it or we can traverse through it while going from one node to other, but if it is present after these elements in the list, then we'll have to come back to it, right? So this is the whole essence of the problem. Now they just asked the minimum time for us to travel through the whole path. So basically, in this particular example, let us see 1 comma 1 is this particular point, this point right here, and then they go to 3 comma 4, that is this point here, right? So this is the shortest path that they have followed. So the thing that you can do is, you can either go up or down or left or right, or in any of the 4 diagonals, right? You can travel like this. So how do I know this? This is vertically, this is horizontally, and diagonally by square root 2 units. So if this is 1 unit, this is 1 unit, this is going to be square root of 2 units, right, by Pythagoras theorem. So that means you can go diagonally like this. Now what you have to do is, you just have to find the time taken in the shortest path. So in any case, let me show you with an example. So if you have a grid, so let's assume that this is going to be a 2D grid, and these are the points, right? So this is 1 point, this is 1 point, this is second point, this is third point, 4 point, 5 point, right? So let us assume that these are the points that we have. Now let's say you are at this particular position and you want to go here, right? So what will be the shortest path? Now you would always want to constantly move towards this particular point, right? So I'm going to go from this particular, I'm going to go like this, right? So what I'm essentially trying to do is, I'm trying to cover as much as diagonal element as possible, right? And when I know that I cannot cover any diagonal element more, I will directly go to this particular point, right, like this. This would be the most optimal path to travel in this particular case, right? You understand why? Because I am always trying to cover the most diagonal path possible. So whenever, let's say I calculate the difference in the coordinates, so let's say this is 0 0 and this is going to be let's say 1 2 3 and 1 2 3 4, right? So this is 3 comma 4, right? So what is the maximum diagonal element that I can travel? That will be 3, right? Because this is the minimum of the two. So let's say I write minimum, right? And now the remaining element will be maximum minus minimum, right? Because since I have traveled 3 from both, so this is going to be 0 comma 1. Now the difference is 0 1, right? That means I have to travel 0 units in the x direction and I have to travel 1 units in the y direction. So I'll have to add max minus min, max minus min. Now these two minimums will cancel each other, and that means that minimum path or the optimal path will take max units of time. That is the maximum among these two values. So what are these two values? This is the difference in the coordinates, right? So if I am starting from 0, 0, I have to go to 3, 4, then the difference in coordinates in 3 and 4, right? So this is the difference in x, this is the difference in y. Let's say I travel 3 units diagonally, then the difference in x will be 0 and the difference in y will be 1. So I'll have to travel this additional unit separately in the y direction, right? So now what will happen? Once I do all the math and I always know that my answer is going to be the maximum of these two dx and dy, right? So this is how you could easily solve this problem, and that is exactly what I have done. I've initialized my answer with 0 and I'm just going through all the points. So I calculate the value of dx and dy, so that is just the change in the x coordinate and the y coordinate, and you can just add maximum of dx comma dy to your answer and return your answer at the end, right? So this is how you could solve this problem. And let me just quickly submit this and show you that this particular solution works. So you see, passes all the test cases and the solution is correct. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video, and don't forget to share thoughts in the comments, because your engagement with this video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.